Hello, SWK 351. It's James here. We're in chapter 15. And what we're doing in chapter 15 is we're returning to this idea of a correlation coefficient because we can actually run a statistical test that involves that correlation coefficient. And really, long story short, we'll set up our null hypothesis and research hypothesis and then compute our correlation coefficient. Then all we have to do is determine the degrees of freedom, and then we can look up a chart to see if our correlation coefficient is statistically significant or not. So that's really the kind of very shorthand version of this whole chapter. And so I'm looking at page 256, 257, and looking at the null and research hypotheses. When we're doing a statistical test on the correlation coefficient, we're starting with this null hypothesis that there is no relationship between between our input variable and our predictor variable. And in this case, it's the context is an indicator for quality of marriage for between married people, and then the quality of the parent-child relationship. And so kind of essentially we're saying is there a correlation between these two variables? And it's important to note that we're using quality of marriage as the predictor variable and the quality of the parent-child relationship as the response variable, because what we were given in this context was that researchers wanted to see if the quality of marriage score was a good predictor for the quality of the parent-child relationship. Now, since this is a correlation, I do suggest running a scatter plot on this. And you can review how we did that previously. And you can generate a scatter plot. But what we'll do is we'll go ahead and run this correlation here. It's going to be very similar to what we've done in the past. So we have our correlation, and then for our input range, I'm going to select this whole rectangle for both of the columns. For my input range, I do have the labels in the first row, and then I will output the results here. Okay, so here is our correlation coefficient. You'll note that that is different from the correlation coefficient that's printed in the book. I believe that they made an error in their calculation. I think they used the first 17 values and not all 30 values that were included in the data set. Now for the degrees of freedom, well, there are 30 pairs of data values, and for this particular correlation coefficient situation, we take that 30 and subtract 2 away from it. And that gives us a degrees of freedom for 28. So when you do your homework assignment for chapter 15, your degrees of freedom is your number of data pairs minus 2. That's how we get our degrees of freedom. So we have our correlation coefficient, we have our degrees of freedom, and now what we need to do is to take a look at, I believe it's table B4. And what table B4 does, I went ahead and scanned it so we can see it on here. This is page 362. This is just a list of critical correlation coefficients for the same degrees of freedom. And we have two critical levels, the 0.05 level and the 0.01 level. That would be like our alpha. Okay, so in this case, our null hypothesis was that there was no relationship. The research hypothesis was that there was some relationship, but we didn't specify if it was a positive correlation or a negative correlation. So that means we're going to use a two-tailed test. We're going to be in this set of columns here, and we have 28 degrees of freedom. So I'm on page 362 with 28 degrees of freedom. Now the way this works is once we get to larger sample sizes, you'll note that we go from 20 to 25 to 30. Now the 28 would be in between here, so we have to choose either the 30 or the 25, okay? Well, we actually choose the 25, and the reason is that it's harder to because it's harder to reject the null hypothesis with a smaller sample size. So what we can say is if we can reject the null hypothesis for a sample or for 25 degrees of freedom, we know that we can also reject for 28 degrees of freedom. So we're using a slightly different value there. And I'm coming back up here to this 0.05, that's what we've been using. So this is the value that I need. What this tells us is if our correlation coefficient is 0.3809 or larger, then we would reject the null hypothesis. So this is our comparison value. And when we come back here, we have the 0.437. So we have our correlation coefficient of R, which was 0.437, and our critical or our comparison value. Yeah, our comparison value, our critical value was, just go back over here, 0.3809. And so since our correlation coefficient is more extreme, it's larger than the 0.3809, we reject the null hypothesis. And that's how we run a statistical test on the correlation coefficient. So our conclusion then, and this is very similar to what we have in the book, we cannot accept the null hypothesis. So we would say we believe we have evidence to suggest that there is a correlation between the quality of marriage score and the quality of the parent-child relationship, and that that correlation is not just by chance alone.